As climate change intensifies, rice self-sufficiency in Africa will become more difficult. However, on the premise that compensation for greenhouse gas reduction will be realized, let me introduce an innovative method that can simultaneously solve African rice self-sufficiency and large-scale greenhouse gas reduction. Rice is the fastest growing staple food in Africa. Africa's rice production has been growing steadily for decades, but it cannot afford the fastest growing consumption. Therefore, the import is gradually increasing. Africa has more than 600 million hectares of uncultivated arable land, of which tropical savanna and monsoon regions that make up most of sub-Saharan Africa have abundant rain. So why do most African countries import rice? The reason can be guessed by comparing the yields of Northern Africa with other regions. In this table, Northern Africa refers to Egypt where rice is grown in the Nile Delta and the yields at least 3 times higher than other regions. Why is Egypt's yield overwhelmingly higher than in other regions? Because they can use the Nile to grow rice in water. So, is rice an aquatic plant? The answer is no. The scientific fact is that all cultivated rice is not aquatic but just water intensive. Rice can grow better outside the water rather than in the water. But without water, the most populous aerobic weeds dominate the field, leaving little rice to harvest. After all, the reason Africa imports rice continuously is because the land is large and lacks the money to equip expensive irrigation facilities such as dams and reservoirs. However, Egypt, which boasted the world's highest yield by the Nile, also recently started importing rice due to lack of water. Until the rice is harvested, irrigated rice farming usually consumes 100 centimeters of water. In other words, to produce 1 kilogram of rice, usually 2 to 3 tons of water is inevitable, and it's estimated that about 30% of the world's fresh water is used to irrigate rice fields. In addition, when rice is grown in water, anaerobic decomposition of organic matter in the rice paddy emits a huge amount of methane. Rice cultivation accounts for about 2.5% of global greenhouse gases. Irrigated rice, which requires 10,000 tons of water per hectare, is highly vulnerable to climate disasters such as drought and rising sea levels, exacerbating climate change by emitting 10 tons of carbon dioxide per hectare. As climate disasters such as drought and sea level rise intensify, rice self-sufficiency in Africa is expected to become more difficult. However, on the premise that compensation for greenhouse gas reduction will be realized, I will introduce rice farming using biofilm with seed attached that can simultaneously solve African rice self-sufficiency and large-scale greenhouse gas reduction. To produce about 17 million tons of rice imported by Africa, at least 40 million tons of carbon dioxide emissions are inevitable, given the yield of the exporting countries such as India, Thailand, and Vietnam. Because rice grows in water, methane is produced. Rice cultivation outside the water while controlling weeds with a biodegradable film makes methane-free rice farming possible. The best places are the rain-fed upland in Africa belonging to tropical savanna and monsoon areas. According to Rice Almanac 2013, rain-fed uplands produce 1 ton of paddy rice per hectare, while irrigated fields produce 5.5 tons. In other words, rice yields a lot when grown in water. Given that the West African paddy rice price is about $300 per ton, and the farming cost is about $1,000 per hectare, farmers suffer losses if they cannot produce more than 3 tons per hectare. Upland rice yielding only 1 ton is not a business, but subsistence agriculture to avoid hunger. The farmers here are always poor because there's no rice to sell after family consumption. Today, more than 6 tons of paddy rice per hectare can be produced in the irrigated field in most parts of Africa. In addition, rain-fed lowland in many river basins and coastal deltas are continually being converted to irrigated fields to increase the rice production. Nevertheless, the area of irrigated field is limited, which makes it impossible to meet the increasing consumption. It's inevitable to continuously expand rice imports. For this reason, I insist that it's worth paying attention to the rain-fed upland in Africa that have been neglected so far. Here is the upland rice farming using biofilm that will replace irrigated rice farming. Biofilm not only control weeds but also prevent the loss of temperature, humidity, fertilizer, and provide an optimal environment for growing rice, resulting in high yield. Of course, since rice is grown outside the water, it doesn't emit methane. This is seed film cultivation. Seed attacher attaches seed to the biofilm using eco-friendly adhesive while simultaneously creating germination gaps on the both sides of the seed. The biofilm with seed attached is called seed film. Spread the seed film on dry field so that the seed face the ground. Cover the seed area with soil and cultivate it with rainwater. If the rain is low, you can use sprinkler, pivot irrigation, and drip irrigation to irrigate secondary. The biggest advantage of seed film cultivation is seedbed formed by biofilm. Seedbeds, usually made in greenhouse, are essential for making good seedling, but direct sowing is not supposed to have seedbed. Seed film cultivation is also direct sowing, but in itself forms seedbed by biofilm mulching. When the seed film is mulched and covered with soil, the bottom of the film becomes like a greenhouse, forming a seedbed, preventing the loss of temperature, humidity, fertilizer, providing an optimal environment for seed germination and rice growth. Here, more than 8 tons per hectare were produced in China. Here, more than 8 tons per hectare were produced in China. Upland rice farming, which yields less than 2 tons of paddy rice, is not a business but subsistence agriculture to avoid hunger. However, upland seed film cultivation, which can produce more than irrigated field, turns upland rice farming into profitable business. As farmers benefit, they will expand their cultivation area in the upland. Subsistence farmers in rain-fed upland will be rich and the country will be less dependent on rice import. So, how can upland rice farmer in Africa grow rice with seed film cultivation? Who will provide the biofilm? It's a known fact that 10 tons of carbon dioxide are emitted per hectare of irrigated rice field per crop season. However, 1 hectare of biofilm also emits about 1 ton of carbon dioxide throughout the entire processes, including raw material, film extrusion, and decomposition. Therefore, when biofilm is used in upland rice farming, about 9 tons are mitigated. Based on the recently announced IMF's claim of $75 per ton of carbon tax, upland seed film cultivation have the right to receive compensation of about $675 per hectare. This amount exceeds the cost of biofilm, so in simple terms, the film can be supplied to farmers free of charge. The best example to demonstrate the value of upland seed film cultivation is African rice self-sufficiency using this technology. Let's take a look again at the current production import of African rice. With upland seed film cultivation, it's not difficult to increase paddy rice yield to 6 tons per hectare in Western, Middle, and Eastern Africa where there is enough rain. By doing so, Africa will not only be self-sufficient in rice, but will also become the world's largest rice exporter. At the same time, it will mitigate more than 40 million tons of carbon dioxide each year.